how do these regulatory frameworks,
whatever equipments we are giving it to them, whatever instruments, the tank, everything has to have certification.
a common misconception people have about water treatment systems?
That the post-treatment is very important.
Compliance or technology?
Compliance, because compliance defines the technology.
Today, we are diving into the critical role of high purity water systems in pharmaceutical manufacturing. And to help us unpack both the technical and operational aspects of this, we are joined by someone who has spent nearly 2 decades working across industrial water systems and automation, and comes with extensive expertise in utilities and processes of the pharmaceutical industry. Welcome, Rahul.
Thank you. Glad to be here and looking forward to have a wonderful conversation.
Shall we begin?
Yes.
So, to begin with the fundamentals, what exactly is high purity water and where is it used in the pharmaceutical industry?
Okay. So high purity water itself, if we call it high purity water or purified water, it is actually it's in purest form. The water it's in purest form. So the high purity water systems is a treatment process which takes raw water to that purest form. So if we talk about pharmaceutical industry, which we are currently talking, so pharmaceutical industry needs a very high purity water, because the application wise, it is actually used for directly manufacturing of your medicine or to wash or rinse the equipments which are used for manufacturing of the medicine. Okay. So it has to be its purest form. So it is not like a typical industrial water or treatment plant what we have. So then again, if I talk about parameters wise, the typical boiler feed, if you talk about industrial water, a boiler feed water will be 20 or 50 TDS. Here in high purity water, we are talking about less than 1.3 microsiemens per centimeter. We are talking about TOC of less than 500 ppb, a microbial limit of less than 100 CFU per ml. So these are the kind of parameters we talk when we discuss on, like when we talk about high purity water systems.
So now that you've mentioned that, the standards are very, very precise for this, but what exactly does, define, what makes pharmaceutical grade water different from water systems, say, which we use in industrial or domestic applications?
Okay. So first we have to understand how industry actually, if you talk about industrial water treatment plant, basically it will be for boiler feed, boiler makeup, cooling tower makeup, or maybe for, let's say, for gardening, if you talk about domestic. So there the parameters are not that critical. Okay. So typically the water system is designed, so there are 3 impurities basically in the water. If I talk about, one is your physical, one is chemical. So the industrial water treatment plant are more or less designed to remove this kind of impurities. But when it comes to microbial impurities, the bacterial impurities or a biological, if I talk about pathogens, if I talk about pseudomonas, if I talk about staphylococcus, these are kind of pathogens, which should not be present when we talk about purified water or water for injection. So the treatment process becomes different at the post-treatment level. Okay. So when I design a boiler feed water or an industrial water treatment plant, which doesn't require a pathogen-free water, I will not think about that, when I design the system. But even though there is a pathogen present in the raw water, but when I want to design a purified water system, and if the pathogens are present in the raw water, I'll put ozonation system. Okay, because pathogens should be absent when we talk about high purity water system. The microbial load should be less than 100 CFU per ml when we talk about purified water. So that makes it totally different. And even though if I talk about construction point of view, okay, so there in your purified water, there should not be a hold up, any hold up of water at any point of time in the post-treatment area or at the distribution area will actually have your microbial growth or microbial contamination into the piping, which is not in the case of industrial water, right? You are not bothered about microbial contamination in the industrial water, but in purified water, yes, it is very important. So what we do is the construction or the MOCs what we consider when we design the purified water system or a WFI system, we take MOCs like SS316L, which will be internally electropolished. We will ensure that there are no dead lags, there is no hold up volume. So the valves what we select will be as per that. So then the instruments what we use will be sanitary type. Okay, so there won't be any hold up. The fittings what we'll be using, that will be sanitary type. So all these things will be taken care when we design the purified water system, which are not that critical when you design pre-treatment water for boiler feed.
Or for domestic or
For
industrial?
domestic purpose, yes.
We often hear about different categories such as purified water, water for injection, ultra pure water. Could you explain how these grades are different and what are their applications in the pharmaceutical industry?
So I would say application wise, so in pharmaceutical company, there are different industries. Okay, so in pharmaceuticals also, there are sub industries starting from intermediates, then your active pharmaceutical ingredients, then you have formulations. So if I talk about intermediates, it's a basic raw material, Then API, which is active pharmaceutical ingredients. For API, the raw material will be intermediates. So and formulation is actually combination of API. It's a final finished product what we have. So as and when the product, the raw material gets changed or the end product gets changed, the type of water, the type of quality of water which is required gets changed. So typically when you have a OSD, like oral solid dosages, where it is tablets or cough syrup, you need purified water. Okay. When there is a injectable or vaccine manufacturing facility, you need purified water also, you need water for injection also. So what is purified water? So if you have a raw water, you treat it, you take it to purified water, and after that, so if you compare the parameters between purified water and WFI, so the purified water parameter will be, if you talk about microbial, the total bacterial count, it will be less than 100 CFU per ml in purified water, whereas in WFI it is 10 CFU per 100 ml. So it is very, very stringent. Okay. So the purified water becomes feed for your water for injection. So you have to generate purified water first, qualify it, then it can go to your water for injection generation plant. Then when we talk about ultra pure water, so there is a current boom actually in the semiconductor industry, your solar, your chip, microchip. Over there in process, you require ultra pure water. So ultra pure is far more pure than your purified water. So if I talk about the parameter per se, it will be your purified water conductivity will be less than 1.3 microsiemens per centimeter. But in ultra pure water, it will be 18 megaohms, which is equivalent to 0.05 microsiemens per centimeter. So it depends on the application. Okay, it depends on the application where it is getting used. In pharmaceutical also, at what temperature you need water. So purified water is typically at the ambient temperature. Water for injection is at 80 degree Celsius. Sometimes it is cooled down also to certain temperature. So there are different parameters, there are different applications, different products define what kind of water you need. But basically it derived upon API formulations, OSD, injectable vaccines.
Okay. Okay. So clearly the standards for pharmaceutical manufacturing are quite high, and obviously this becomes one of the most regulated industries in the world. What kind of regulatory frameworks govern high purity water systems?
Okay. So see, we have to understand first that why it requires regulatory framework basically. So why means because it is actually a raw material for your manufacturing of medicines. Okay. So if you take any medicine, so at the back it will have batch number and everything. All will be documented, right? It's all documented. So when you are producing water to manufacture a particular medicine, almost it has to be also to follow that regulatory process. So it's generally defined by the country which you are exporting. So let's take an example that there is a manufacturing facility based out of India in Hyderabad, for example, and they are planning to set up a plant which will ultimately export the medicines to US market. So they have to follow United States pharmacopoeia. Then you have Japanese pharmacopoeia, then you have European pharmacopoeia. So there are certain standards which has been set by those countries. Okay, so whoever wants to manufacture the medicine for their country has to follow the guidelines which are written in their particular pharmacopoeia. But what we feel like, what we have seen is USP is mostly the benchmark. European pharmacopoeia is slightly, if I talk about basic difference in water, United States pharmacopoeia, USP will not have a endotoxin as a limiting parameters for purified water, which is 0.25 EU per ml, but European pharmacopoeia will have.
Okay.
So that is, there are typical difference. And if I talk about Indian pharmacopoeia, so just like if there is any amendment in United States pharmacopoeia, if there is any amendment in United States pharmacopoeia, Indian pharmacopoeia will implement that within 2 years. So that typically happens. So if there is any change in USP, there will be change in IP, not immediately, but after 1 or 2 years.
So like definitely these new processes, they ensure that, high standards are met. And obviously over the past 2 decades, a lot of things have changed. How has automation and digital monitoring, impacted the way pharmaceutical water systems are designed and operated?
Okay. If I talk about online monitoring, so if I talk about the total organic carbon as a parameter, which is very important in case of purified water, in case of water for injection, in earlier days, it used to be a offline measurement. Okay. So they have to collect the sample, take it to lab. There used to be a lot of errors into that. Then came online monitoring of TOC analyzer. So now we are giving an online instrument. Again, it has evolved. So earlier there used to be only 2 makes. Now we have like 8 or 10 makes options available with us to offer to customer. Now the new technology which is coming, which is microbial, rapid microbial monitoring system. So typically a microbial, if you want to measure, which is again an important parameter, 100 CFU per ml, the sample has to be collected, it has to be taken to lab, cultivated, because microbial you will not see, right? It will take some time, 1 or 2 days. So now the new technology which is coming up is rapid microbial monitoring system, which will get evolved eventually, same like what TOC has. So since it's a very critical system, automation plays a very important role in terms of data.
So definitely over the past 20 years, you've seen how the industry has evolved, how things have changed. So from a technological standpoint, what innovations are currently shaping the future of pharmaceutical water systems?
So if I talk about innovation, see the output parameter of purified water for injections are set. Okay. The unit operation which are required to manufacture this or to produce this kind of water is also there. These are typical water systems. What has now is getting evolved is how you improve the plant efficiency. There is a whole lot of sustainability things which is happening, right? So under this, yes, there are new technology which are coming up. One technology which I can tell you is vapor compression distillation technology. So vapor compression distillation is the alternative method of multi-column distillation plant used for water for injection generation. So typically what happens is when you want to generate a water for injection from multi-column distillation plant, the feed condition to your multi-column distillation plant should be purified water. Whereas in vapor compression distillation technology, you can give a RO water, a first class RO water, a less than 100 ppm TDS water directly. So what you eliminate here? You eliminate the complete purified water generation system, the storage and distribution complete part. But again the catch is, some companies will require purified water also, some companies will require water for injection also. So in case, if you take an example of large volume parenterals, okay, that is your saline water or something, where your water for injection consumption is very high, and you are producing purified water just to produce WFI.
Okay.
Then the vapor compression distillation becomes a very viable option, because you don't need purified water, right? You need only WFI.
So that's definitely going to save a lot of time and money.
So that is one part. Now, again, one new thing is which is coming, which is already there in US, which is cold WFI. So typically, if you talk about WFI, it is at 80 degrees Celsius. But some process requires WFI at 25 degree at 40 degree, depending on the process. So in previous days, they used to have an offline heat exchanger, and it used to take lot of time to bring to from 80 degree to 45 degree. So now this cold WFI generation system has came. So it typically, so you compare, so it is again with the membrane separation method only, with the RO membrane and everything. So there is a difference between purified water and there is a difference between WFI parameters wise. I told you, right, microbial and this thing. So you will have a unit operations, let's say ozone technology in your pre-treatment, ozone technology in your post-treatment to eliminate that. But the main challenge what we face when we talk about pharmaceutical, because these, the ROEDI system, the multi-column distillation plant are proven technology in industry. First we have to understand, this is like a raw material for a company, right? So any breakdown in the system, any breakdown in the plant will cost you a production cost, right? So typically customer is already having a risk assessment, or the operators are aware, if the system gets breakdown, what needs to be done. The risk plan is already there. But when we talk about new technology, it is not there.
We don't know what will happen.
Because these are not, see, these ROEDA systems are running from like 20-25 years. We have evolved as an OEM. How we used to design the system earlier, what interlocks we used to put before, now we have changed. We have also evolved, the industry has also evolved. So similar way, if I talk about new technology, customer is little bit,
Hesitant.
He's thinking that, why we should go with, let it, And one more point is, even though, so if I talk about vapor compression and water for injection, there will be a huge saving in terms of steam consumption, in terms of water saving, in terms of sampling. But the initial investment of vapor compression versus multi-column will be very higher. So why to put investment on this? Even though he'll get a ROI of 2.5-3 years, but still he will say that no. And see what we have seen in pharmaceutical industry, let neighbor first have that system. Like the similar product, for example, if the company is manufacturing X product, similar product, and with the vapor compression distillation, it becomes very easy to convince the other customer who's making the same product. Okay. So that is there. So it actually, so now the things are changing. Maybe we can say like after 2 to 3 years, there is going to be change, because there is a lot of things which are happening on the sustainability front. So under that, of course, there will be new technology, acceptance on the new technology which will come up.
Great to know that. Well, Rahul, thank you for being here and helping us understand the intricacies of what goes behind pharmaceutical water treatment systems. Thank you again for being with us. Thank you for your time.
Thank you.